All right, so we are still on section 3.6. This is going to be 3.6 part 1, still video number 3. So approximating using Simpson's rule. So Simpson's rule is new to us. And Simpson's rule, what they do, so we have on the left-hand side, this is what our equation would look like if we used, so this is broken up into two intervals. So we have from x sub 0 to x sub 1, and then from x sub 1 to x sub 2. So if we made this whole interval just 1, from x sub 0 to x sub 2, with Simpson's rule, what they do is they write a quadratic equation. Okay. So we went from just using a midpoint value to using the two endpoints and making trapezoid rule, to now what we're going to do is make a quadratic equation. So f of x is the curve of the equation that we want to find. P of x is a quadratic equation that we want to make very close to our f of x function. So if you look over here to the right, now we're breaking this up into smaller pieces. So now we have 4 different intervals, and we're taking 2 intervals to write one quadratic equation. Okay, so we've got these 2 intervals, and then the 3rd and 4th intervals are a second quadratic equation. So this p of x, p of x and p sub 1 of x, p sub 2 of x, these represent a quadratic equation for a function. So if we take the smaller the subintervals that we take, just like we talked about with the rule of integration, the smaller the subintervals are, the closer we get to the actual function. So we're taking 2 subintervals and using those 2 subintervals to write a quadratic equation. So let me go to the book on OpenStax, and we'll look at that in the rule, or the proof of Simpson's rule real quick. Okay, so we're going to look at just a real quick overview of Simpson's rule. I've already spent a long time on this first part already with my videos, so we'll try to do this quickly. So looking at these pictures and these equations, you can see that our function, which is our original function that we want to integrate, at x sub 0, we're going to say f of x sub 0 is equal to p of x sub 0. So remember, p is the new quadratic equation that we want to write, and that is equal to a x sub 0 squared plus bx sub 0 plus c. So they are just taking these two. They're saying at x sub 0 we're going to put a point on the function that is a point for the function, also a point for the quadratic equation, and then when we plug it into the quadratic formula, this ax squared plus bx plus c, plug x sub 0 in for all of those. Okay, so we're saying that all of those are going to be equal to one another. And then we're going to do that for every point within p sub 1 of x. Okay, so they're just using p sub 1 of x right there to show how to write an equation for that. So we need 3 separate points given on this interval right here so that we can write an equation given those 3 separate points. Okay, so now we're going to move down. So we've got those 3 points written in quadratic format. Okay. Also have found the delta x. So if we look back up at that picture, remember that delta x, so our first interval, we're going to take 2 intervals to write this equation. So delta x is x sub 2 minus, I guess I shouldn't be pointing at my screen, you can't see that. It's going to be x sub 2 minus x sub 0, and then divided by, and that's going to equal 2. All right, so see right here, that's going to equal 2 delta x's. So we have our subintervals, x sub 0 to x sub 1, x sub 1 to x sub 2. When we are writing these quadratic equations, we always take 2 subintervals. Okay, so x sub 2 minus x sub 0 is equal to 2 times delta x, which means that delta x is going to equal x sub 2 minus x sub 0 over 2. And also x sub 1, all right, so x sub 1 is the midpoint. So because x sub 1 is the midpoint, we know that x sub 1 is going to equal x sub 2 over x sub 0, all divided by 2, because it's a midpoint of x sub 2 and x sub 0. Okay, so then I'm really not going to go through all of this. It is in the book if you want to go back through and look at it. But what they do is they integrate between x sub 0, x sub 2 of f of x, say that's approximately going to be approximately equal to our new quadratic equation, p of x that we write. And our equation p of x is written in the format of ax squared plus bx plus c. So they're just integrating a very, very generic quadratic equation from the points x sub 0 to x sub 2. All of that really means nothing. All they're doing is integrating just a very, very basic equation, resubstituting things back in. Then when you get down here to this point, this is just rearranging. It's almost kind of feels like a partial fractions type of thing that you're doing here, but you're just doing a lot of algebra with variables and a lot of different variables. But once you get down to here, we're going to have delta x over 3. That's going to stay part of our formula. And then we have f of x sub 2 plus f of x sub 0. That comes from plugging those points back in after we evaluate. And then we also have our quadratic equation that you're plugging back in after you evaluate. And the twos there, we've got all of those that come from the integration. When you have a times 2x sub 1 squared, you can factor that 2 out as a 4. And then here also we can factor this 2 out also as a 4 out in front. So you end up with 4 times f of x sub 1. Now, if I had my way here, I would show that on, at this point right here, my tablet went to sleep, I haven't used it enough, here we go, delta x over 3 times f of x sub 0, so that's going to be your first side that we use, plus 4, and that 4 comes from integrating that quadratic equation and then pulling out those numbers out front. The 2 is going to be squared, so it's going to come out as a 4. 2 times 2 is going to be 4, so that's going to be 4 times f of x sub 1, and then plus f of x sub 0. Well, this is all just for the p sub 1 of x, but remember back up in our picture, we had our second quadratic equation right here, p sub 2 of x, that's using the side endpoints x sub 2 to x sub 4 with a middle point as x sub 3. So those points are all going to be used. We'll do the whole thing again for p sub 2 of x, and then we would have to add it on. Where were we? We would have to add it on here. So if we were going to go on and add on a p sub 2 of x, so our second quadratic equation, then what we're going to add, it uses the endpoint f of x sub 3, so we're going to get another f of x sub 3 plus 4 times f of x sub 4, which is the middle one, and then plus f of x sub 5. So what happens is every time we add on a new polynomial or a new quadratic equation, the last of the first equation and the first of the last equation will add together and we'll end up with 2. So that's how we get this formula here. The delta x over 3, that comes out with the integration. And you can follow through with how they integrated that if you want to know where that 3 comes from. The f of x is the first endpoint. X sub 0 is the first endpoint. X sub 1 is the middle endpoint of the first quadratic equation. So it has to be multiplied by 4. Then the x sub 2 is that last endpoint. Well, if we're going to add on another polynomial onto it, or another quadratic equation, we're going to end up with 2 of them. Then the 4, f of x sub 3, that x sub 3 is another midpoint of the second quadratic equation, so it has a 4 in front of it. Okay, and so on. So what you end up getting is you end up getting an equation that alternates between 4 and 2, 4 and 2, all the way through. Again, just like our trapezoid rule, our very first term is going to have a coefficient of 1 always, and the very last term is always going to have a coefficient of 1. Okay, so let's look at an example using Simpson's rule. Okay, so we're going to use x cubed this time. I didn't want to use x squared with the Simpsons rule because we're using a quadratic equation. Yeah, that really wouldn't go very well. So we're going to look at something that's not a quadratic equation to use that Simpsons rule with. So we have our equation, integral from 0 to 1 of x cubed, and we are going to use 4 subintervals. So just like the other ones, we need to know what n is. N is equal to 4. We also need to know what delta x is. And delta x is going to be equal to 1 minus 0 over 4, so again 1/4. And then we are going to use s sub 4 to represent that we are finding this area using Simpson's rule with 4 subintervals. The very first part is delta x over 3 times f of x sub 0, so our first endpoint, plus 4 times f of x sub 1, our second value, our second endpoint, plus 2 times f of x sub 2. So let's get at least that far, and then we'll finish up. But this is the pattern that we need to use. The first is 1, the last is coefficient is 1. And then we're going to alternate between 4 and 2 in the middle. So a lot like the trapezoid rule, except for the trapezoid rule out here in front, we would have a 1/2 instead of a 1/3. And then we would have 2's in front of everything. This time we have 4's alternating with those 2's on our Simpsons rule. Okay, so cubic function, we're going to be coming up like that and then up. So between 0 and 1, we have 4 intervals. So again at 1/2, 1, 1/4, and 3/4. Okay. So we are going to write this into our formula. Delta x is equal to 1/4. So we'll have 1/4 times 1/3, which 1/3 comes with the equation for the Simpsons formula. And then we'll have f of x sub 0. Well, let's list our endpoints here. It's always a good thing to do with any of this numerical integration, is list your endpoints. So my first endpoint is going to be 0. That's where I'm starting off. And then to 1/4, 1/2, 3/4, and ending at 1. So those are all the endpoints that I need to use in my Simpsons rule. So we're going to have f of 0 plus 4 f of 1/4 plus 2 f of 1/2, 1/4, 1/2. So we did 4, 2, we still have 2 more. So we got to do a 4 again of f of 3/4. And then plus 1 times f of 1. So that last one, we need to keep a coefficient of 1 on there. Okay, I'm getting really short on time again here. So I'm going to pause here just for a second, make sure I've got all of this figured out right, and then I'll come back with the solution. Okay, so we're going to have 1/12 here, and then f of 0, of course, is going to be 0. And then we're just going to go through and cube all of these. So 4 times 1 over 64 plus 2 times 2 times 1/8, right? And so on. So just plug those into your equation up there, the x cubed, and you'll end up with a final answer of 1/4. Put all that into your calculator. That should all equal 1/4. Make sure you've got your parentheses on there, and then multiply it by 1/12. And your final answer will be 1/4. And if we look at the integral from 0 to 1 of x cubed, go ahead and integrate that. You will also end up with an answer of 1/4. So you can see Simpson's rule works really, really, really well and is a very close approximation most of the time. It's better than the trapezoid rule and is better than that midpoint rule. Also better to figure out than the midpoint rule. Midpoint rule is pretty hard to calculate, a lot of tedious algebra in that one. But we like the Simpsons rule, it helps us approximate.